my name, for those that you don't know, is Jonathan Gordon. I'm the directing analyst with TakePoint Research. My research and consulting work is focused primarily on education and informing, I guess, sharing knowledge and insights with companies that are trying to better secure their industrial operations and assets and infrastructure and the like. So I spend a lot of time listening, some time talking to people on the front lines like yourselves. And I find this space fascinating. So I always look forward to the opportunity to discuss and to learn. So that's me. Andrew is probably someone that doesn't need an introduction, but just in case, Andrew, why don't you say a few words?
Sure thing. I'm the hello everyone, and thank you for joining us. I'm the VP Industrial Security at Waterfall Security Solutions. My background, I spent about a decade developing industrial control system products for various vendors. I spent a half decade developing IT/OT middleware products that connected a lot of control systems to SAP, thereby interconnecting a lot of IT and OT networks and contributing to the cybersecurity problems that now plague many industries. My apologies. In a sense, I got religion. I wound up the chief technology officer at Industrial Defender, trying to, start securing these industrial enterprises. And now I'm with Waterfall, where I lead a team of subject matter experts that work with the world's most secure industrial sites. And I'm here to share some of the learnings and some of the things that the world's most secure sites do differently.
Great. Perfect. Thank you, Andrew. So Andrew's going to shortly run us through some of the detailed analysis around some of the latest attacks over the last couple of years, primarily focused on ICS in industrial networks. And for anybody in the field, I guess I don't have to tell you that it's been a phenomenal year, last 12 months or 18 months or so. Many different sectors were targeted. Many high-profile attacks, a lot of near misses, some hits that caused particularly halts and interruption to production and operational networks. So plenty of names come to mind: the Oldsmar Water, Colonial Pipeline, a lot of manufacturing, Westrock, JBS Foods, Molson, many attacks that sort of hit the press. And I guess the question on everyone's mind is what's changed? Why now? Why are we seeing this massive increase in attacks? And we do have a few ideas on that. So first and foremost, I guess, would be the geopolitical situation. I think it's quite obvious to everyone and painfully reflected in the cyber field that nation-state attacks are becoming very commonplace. And I think we just have to look at the invasion of the Ukraine and seeing the massive increase and a significant increase in the types of offensive cyber attacks in all directions. It's case in point. Just yesterday or the day before, I was reading about a German, I think it was a wind energy production company that was targeted. And it was a company that specializes in manufacturing and maintenance of wind turbines. And the company was hacked, and the remote control systems for about 2,000 wind turbines across Germany were down for about a day. And that's just one example of the increase in attacks that we've seen with regards to the geopolitics. I think also the regulatory environment has changed. We've seen significant momentum building in that area in the US with initiatives like the president's executive order. But it's not just the US. We've seen other regions and other countries follow suit, and the awareness is growing. We've seen a huge amount of awareness coming on the back of this wave. And initiatives like that executive order are forcing some industries and some companies to take a closer look and I guess a more honest look at what they are or aren't doing. And what we see down the road is probably regulation coming and people getting ready for that. So that's another thing that's definitely changed in the last 12 months or so. Ransomware, easy money, big payoff for little effort. There are a lot of soft targets around in the industrial space. There's plenty of low-hanging fruit. So there are plenty of companies that probably thought they could keep a low profile or stay out of the crosshairs, but the hackers know about these companies too. And I think the other critical thing is that a lot of these attacks are indiscriminate. And I think Andrew will go into this as well. The ransomware in particular doesn't need to specifically target operational components or production networks to impact that production or bring operations to a halt. So we've seen numerous examples over the last 12, 18 months of indiscriminate ransomware attacks where even though they weren't designed to specifically target IT or ICS systems, OT or ICS systems, they did succeed in bringing production or services to a halt. And the last part of this picture is the supply chain. And I think hackers have also figured out that if the front gate's being watched and guarded, there might be an easier way in. And the supply chain for many companies is definitely that easy way in. And we've seen hackers taking full advantage of that entry point over the last 12 months or more, SolarWinds, Kaseya, and others. So when that avenue continues to be open to them, they're going to come after the supply chain. So there's some of the reasons and aspects that we've noticed that have caused this sort of increase. Obviously, there's an increase in awareness around the market itself, and that also has an impact. So things are getting more complicated. I don't think there's any question about that. But looking forward and trying to boil everything down, we believe that it all sort of boils down to risk. And it's this fundamental concept of risk. What is risk? What's our appetite for risk? And the biggest challenge for any company, I guess, is really to conceptualize the risk and communicate that risk to any stakeholder within the organization. So across the business, from the board room all the way down to the production floor, it's key to have a common understanding. And Andrew and his team have developed what is essentially, I guess, a model that looks at the top 20 ICS attacks and builds a model where you can actually compare and even the playing field to get a clear understanding of what the risk is to the company and the systems. And no matter what the person's role is, they can easily understand the risk. And essentially what they can do is take a decision based on a common understanding of the risk to the enterprise or to the organization. So that's what we're really going to discuss today. And Andrew, without further ado, I'd like to hand it over to you.
Okay, then let me share my screen here. There we go. How's that?
Yeah, looks good.
Okay. Yeah, so I'm going to be talking about the top 20 cyber attacks on ICS, on industrial control systems. This is a report that came out in 2017. It has, I've got good feedback on it. People have been using it effectively, but it's becoming dated. We have a lot of new data on, new kinds of attacks that are coming after us. And so I'm in the process of updating the report. What you're seeing here is a preview of what's coming in about a month. Everyone on the webinar will get an email with the new report when it issues in about, as I said, 3 to 4 weeks. Let's talk about the threat environment for a second, and then I'll dig into the report. There's a different report that I've just finished, and it's coming out in about a week or 10 days time. And it is with the folks at icsstrive.com. This is a new incident repository. We looked at the year 2021, and the report's a little bit late. 2021 is some months ago. We have an update coming in, the middle of the year. This is the first time we did this, so it took us a while. But what have we learned? What did we learn in 2021? We saw, now the report is focused on process industries. So, think power, oil and gas, even rails, even, food and beverage, focused on process industries and discrete manufacturing, everything from toasters to aircraft. And we're looking, the report is focused on cyber attacks that caused physical consequences, most commonly downtime, but there can be other physical consequences. So when we counted those, we saw that there were 22, and these are public incidents, no private disclosures, no, someone told me this, but I couldn't verify it. This is what's been in the news, in, Bloomberg, in, the Wall Street Journal, in the New York Times, public reports of incidents, cyber incidents with physical consequences. Those reports, we counted 22 of them in those industries in the year 2021. Almost all of those incidents were ransomware. The big headlines, you've heard about here already. There were some near misses. Oldsmar was, big news, but I counted as a near miss because there were no physical consequences. The attack was caught in time before anyone had to issue a boil water advisory, before, there was any measurable impact on the water system in the town. The report also makes some predictions, and I'm going to echo some of the Gartner predictions here. This, and then come into the my own predictions. Mine and Greg Hale's. We put the report together. Gartner's predicting that within, I think it's 2 years, and there's references here on the bottom. Within 2 years, 1/3, or they said 30%, but let's say loosely 1/3 of critical infrastructure providers are going to suffer an outage due to ransomware. That's a huge increase over what we've seen. We've seen public reports, 22, we're predicting more than twice that much next year, or in the this year, in the year 2022. Gartner is also predicting that cyber attacks are going to start targeting safety systems. They're going to start targeting damage to equipment, risks to human life. Basically, they're saying, with their data set, that things are going to get very bad very quickly. So, this is what we have to look forward to. And the problem, a lot of us look at these advanced attack techniques and they say, oh, nation states. I'm not big enough to be a nation state target. I'm not important enough to be a nation state target. What we're observing is that ransomware attack tools and techniques are trailing nation states by only less than 5 years, say 3, 4, 5 years, which means whatever we see the nation states doing to each other today, we should expect ransomware to be doing to all of us within a handful of years. This is bad news because, these are very powerful attack techniques. It's good news, though, in a sense, because we do have a couple of years to start now, get the budgets, fix what's broken, and get ready for the, today's nation state attack techniques coming at us in a small number of years' time. So with that sort of context, let's look at the top 20 report and touch on why it needs to be updated. The report uses 20 standard attacks. These are not the most common attacks. These are a spectrum of attacks that we need to consider between unsophisticated, inconsequential, to very sophisticated, very consequential. And we use these attacks, A, to design our defenses. It's impossible to design effective defenses unless we have an idea of what's coming at us. And B, we can use these sort of a standard set of attacks to evaluate the strength of our defenses, to determine if one defensive posture is in a sense better than the other. We can ask the question, which attacks does the second posture defeat reliably that the first doesn't? And defeating reliably is a high bar. Take antivirus. Does antivirus reliably defeat common malware? Even if the signatures were 100% effective, the answer is no, because it takes time. When are new signatures created? It's when the vendors' honeypots on the internet register a few thousand hits of a new kind of malware. That's when a new signature is created. And if our site gets hit with that malware in the window between the time the malware is released and the time the signature comes out, well, we go down because antivirus didn't save us. So in that sense, antivirus does not completely defeat common malware. But when we're looking at the question, does it defeat? We also need to look at the attack. So let's look at shoulder surfing. If I look over the shoulder of a technician with a lot of access, and I note what their password is, and I log into a firewall or a control system with that password down the road, and do malicious things, if that's the attack scenario, does two-factor defeat that? Well, yes, it does, because even if I've shoulder surfed, I can't use the password. Now, you might imagine, just a minute, maybe you could steal the dongle, or steal the cell phone, or the two-factor thing, and defeat it that way. Well, maybe you could, but that's not a shoulder surfing attack. That's a different attack. So when we evaluate these attacks, we have to evaluate the actual attack, the attack that's described, not an infinite number of variations of the attack. This is, if we want to use this as a ruler, we can't be changing the ruler every time we don't like the outcome of the decision. So that's what we're looking at here. I wanted to spin through sort of these attacks. You get an idea. I don't have time to go through them all. That's a whole different webinar. But we talk about ICS, industrial control system insiders who have passwords and malicious intent. We talk about insiders on IT networks who might shoulder surf the credentials of the industrial insiders and then reach through the firewalls and take things over. We look at targeted ransomware, where the ransomware, is a remote access Trojan. It's reached out to a command and control center. It's being operated remotely, and the malicious actor steals credentials, works their way through the firewall, and plants the ransomware in the OT network, and so on. There's a lot of attacks in the white paper. In the paper, we also evaluate these attacks against different kinds of defensive postures. And so one of the defensive postures is, in a sense, a classic, a best case IEC 62443 posture. 62443 is, of course, the most comprehensive of industrial cybersecurity standards in the world. And when we talk about a comprehensive posture, we're talking about assume that we do absolutely everything. Assume that every device, including the PLCs, has antivirus on it. You and I know this is hard to do, but we assume, in the best case, let's give 62443 its best shot. Put antivirus on everything. Assume that every device is up to date, can be auto updated. The moment the patch comes out, it's applied to the device. You and I know that's not possible in the world of safety equipment, of equipment that's running $300 and $500 million turbines. But in this example, I said, let's assume that. Let's assume the very best case of 62443. We have a single IT/OT interface. It's a firewall. We have a DMZ network. We have all of the defenses that are recommended by 62443. And the bad news is that reliably defeats is a high bar. If you want to defeat these attacks reliably, it's hard. So, for example, targeted ransomware routinely defeats this class of defenses. This is the kind of defenses we see on IT networks more than we see on OT networks. And, there were 4,000 targeted ransomware incidents in 2021 in the IT world. Now we're focused on the OT world, but if IT can't defeat it, there's really, if we assume all of the strongest IT class protections on the OT network, OT isn't going to defeat it reliably either. It'll catch some of them. It won't catch the rest of them. So that's what's going on here. Let's talk about some of the noteworthy changes that are coming. Ransomware took down, as I said, 22 enterprises, multiple sites typically for each ransomware incident in 2021. Took down 22 enterprises. The big news, in a sense, was Colonial. The big surprise with Colonial was that the ransomware never made it into the OT network, and yet the pipeline was shut down. The business said, that's the decision we have to make. We have to shut the pipeline down. This was a deep surprise to a lot of senior decision makers. Everyone assumed, I mean, I assumed that Colonial had a heavily defended OT network. So heavily defended that the ransomware never got in there, and still they shut it down. This was deeply surprising, in a sense, so surprising that, 30 days later, the American TSA, the Transportation brain blank Security Agency, Safety Authority, I think it's, anyhow, the TSA issued a directive to the nation's largest pipelines. And, if you read the directive, there's a lot of stuff in it, but one of the bullets is you will, define your security system for your OT networks such that if your IT network goes down because of a cyber attack, your pipeline will keep running at full capacity. That's the goal. So, like I said, the fact that the pipeline had to be shut down was, as I said, deeply surprising to senior decision makers. Another thing that is a serious, that keeps me awake at night is an attack like the Kaseya attack. Now, Kaseya targeted IT. Kaseya took a bunch of ransomware and distributed it through a cloud-based security update service, distributed the ransomware as if it were a security update, hit over 1,500 organizations. Now, almost no impact on OT. It was IT networks that went down because the IT users were the subscribers to this cloud-based service that had been compromised. But imagine going to a medium-sized industrial control system, hardware or software, let's say software provider, and there's a lot of them out there. I mean, the industrial market is much more fragmented, much more specialized than the IT market. There's a lot of these small and medium-sized providers. Are they all heavily defended? No. Find one that's poorly defended, insert your malware into a security update, press the button, distribute the update, and now we have hundreds of sites, possibly even critical infrastructure sites, going down simultaneously. This is, potentially very bad. So this is sort of some of what's changing. Where did we go here? Here we go. So when we're updating this set of attacks, these are the recent attacks, the recent inputs that I took inspiration from in updating the attack descriptions in the report, in the new version that's coming out. The Iranian passenger rail system was taken down in 2021, presumably by hacktivists, by hacking into signage saying all your trains are delayed or canceled. Unprecedented chaos was the description of the railway stations by the official press. Of course, that description was withdrawn a few hours later, but this is what happened. But it was hacktivist class attacks. As far as the Iranian authorities did not publish a lot of information about the attacks, but from reading between the lines, it did not sound like a sophisticated nation state attack, military grade. This was a bunch of hackers using attack tools they downloaded off the internet, using the knowledge in their heads, just like the attack on the Ukraine power grid in 2015. Again, that attack was credited to Russian nation state actors, but the tools they used were hacktivist class tools. They didn't have to use sophisticated tools, so they didn't. So this is the I'm updating that attack description to mention the more recent attack, which is the Iranian rails attack. OSMA remote access. I did not have a simple steal the remote access password and come in over TeamViewer. I did not have that kind of attack in the original 20. In a sense, it's a trivial attack to defeat. Use two-factor, but two-factor has received so much press in the last couple of years, constantly being, repeatedly being encouraged, the authorities encouraging us to use it, that I thought it deserves to be in the spectrum of attacks. I mean, if you're so badly protected that someone stealing a TeamViewer password is going to take you down, your business decision makers need to know that. They need to see that attack. So I put it in the list. The Kaseya scenario I put in there, I substituted for a different, more complex cloud-based attack. So in a sense, I simplified the cloud-based attack using inspiration from Kaseya. SolarWinds, again, got a lot of press, was actually 2020, but still deserves to be, I think, in the attack set. Stuff was malware was injected into the SolarWinds Orion security update. So I'm postulating that industrial malware is inserted into a security update in this scenario, in the updated scenario. And the thing about the SolarWinds malware, I'm basically saying, let's put in there pretty much exactly what SolarWinds was, but targeting industrial instead of targeting the firewall management product, which was Orion. Targeted ransomware. I have rephrased that attack to better reflect what we're seeing in the wild. The Colonial Pipeline, I've added an attack that says, yeah, the Colonial CEO testified in front of Congress saying the reason we shut the pipeline down was an abundance of caution. It's a safety critical system, even if there was no evidence yet that the attack had drifted into OT, we did not want to take the chance. And so I added the abundance of caution ransomware scenario. Nothing got into OT, but still it was shut down. That's an attack worth having in the set, I think. A question that our business decision makers need to be asking is, if our IT is compromised, will our OT go down? That's an important question. The set of attacks needs to suggest that question. There was a lot of ransomware that took down sites. The classic example is railway systems that went down or had near misses because their ticketing systems went out. So what we have here is a dependence. The OT, the physical operations, correct physical operations, depends on the correct operation of a system on the IT network. And if that system goes down, we have to shut down physical operations. So that's another scenario that is I think, an important question we have to ask. If your IT network is compromised, will critical functions be lost, and we'll have to shut down OT because we didn't do the proper risk analysis, risk assessment on how thoroughly do we need to protect each of these components. Pipe dream is something that's been talked about a lot in the last couple of months. This is the latest sophisticated malware, again attributed to Russian state actors, with a lot of technology built into it to manipulate physical processes. It's clearly, obviously targeting physical processes. And I wanted to add the Pulse VPN, which is a 0-day attack on Pulse VPN servers that's been going on for some time. The attack keeps getting updated, and it defeats two-factor authentication. So we're being encouraged to put two-factor authentication everywhere, but we need a word of caution saying, that's the first step. It's not the last step, because this stuff can be defeated as well. So updating the top 20, what do we get? If we substitute in the pipe dream, I call it targeted destruction, because it's targeted means remotely operated from a command and control center. Targeted destruction, and again, pipe dream had the ability, as far as I can tell, and there's early reports there. I haven't had the ability to confirm all of this by talking to the actual people who did the analysis, but the early reports suggest that pipe dream does not need to be directly controlled from the internet. It can daisy chain its control through intermediate hosts, let's say on the IT network, which in turn have access to the internet, even if the actual target PLCs and whatnot do not have access to the internet. So in the 62443 scenario, I argue that a standard 62443 defensive posture will not reliably defeat pipe dream because of these daisy chaining abilities. The fact that the firewall rules do not permit connectivity with arbitrary internet hosts will not save you. And pipe dream came out before there were antivirus signatures for it, so antivirus won't catch it reliably, et cetera, et cetera. So I argue that it's not defeated reliably. It's defeated some of the time, but not others, by the 62443 measures. Colonial, 62443, you can defend your OT network. I'm guessing that the Colonial Pipeline had a complete 62443 implementation on their OT network, and still they shut the network down. So it's clear that that defensive posture, didn't work. With railways, again, ticketing, you've got IT dependencies. 62443 is focused on the OT network. If IT goes down and we have to shut down operations, it doesn't matter that we have a 62443. So that dependency, an attack on systems with dependencies like that is not gonna save us. 62443 won't save us. Pulse, again, if you hack the two-factor, you're coming in as a trusted insider. So again, the 62443 allows trusted insiders to come in by remote access, is not going to reliably defeat this. Oh, pardon me, I skipped the remote access attack. Two-factor authentication does reliably defeat the Oldsmar class attack, so that's new. It gets a green background. Kaseya, again, you've got a cloud connection that you trust. I mean, we decide we trust the supplier. So we establish a cloud connection. We put the rules in the firewall. We let the connection go out. We let the supplier interact with our systems. And then the supplier becomes compromised. I mean, we trust the supplier, but it was a mistake to trust their website. Not something 62443 has any provisions in to address. And, SolarWinds, the actual SolarWinds attack, I argue, is defeated reliably by a 62443 posture, because it needs to be, now SolarWinds beaconed out to a command and control center on the internet, which is generally possible from IT networks. It's generally not possible from a compliant 62443 implementation, because that compliant implementation does not permit connections to arbitrary hosts on the internet from the trusted OT network. So SolarWinds is reliably defeated by the 62443 posture, or at least that specific instance of the targeted attack. Let's talk zero trust. A lot of people are zero trust is the big buzzword. Does it help here if we do 62443 and add zero trust? And what is zero trust? I define, there's lots of definitions out there. Some of them are really very complicated. I say, look, in my books, zero trust is simple. Zero trust is what I'm doing right now. Okay, I'm on a home network. I work out of my basement. I'm basically on the internet. This laptop can reach the internet. It can be compromised by attacks coming in from the internet. It's an asset on the internet. When I go to my email server, does it say, oh, I know who you are and let me in? No. I need an encrypted connection. I need to give my username and password. I need to give my two-factor, and then I get it. If I go to my bank, same thing. If I go anywhere on the internet where I do anything interesting, I get the same thing. It's encrypted. There's authentication. There's often two-factor. That's zero trust, because nobody trusts each other across the internet. If we do the same thing in our industrial network, if every PLC says, I need an encrypted connection, I know it's not possible with a lot of PLCs, but imagine that we had zero trust everywhere, that every PLC, every device, every server, everything said, you've got to be encrypted to get to me. You've got to send, username and password across. You've got to have permissions to do what you're asking to do. And, I'm going to challenge you for two-factor on every connection. Imagine we had that. I know it in practice, it doesn't work, but imagine that we had that. What would that buy us? Well, it turns out in my analysis that the only thing it buys us is it wipes out pipe dream, because most of the pipe dream exploits are exploits where you connect to a DNP3 device and give it commands. No authentication, no nothing. If you have a foothold on the OT network, on the industrial network, Pipedream lets you connect to Modbus devices and send them commands. Connect to ICCP devices and send them commands. Connect to a wide variety of devices and just send them commands, because you don't need permissions. And so that capability, which is a variation of a man-in-the-middle attack, that capability is wiped out by zero trust. That is the one attack zero trust gives us reliably. I've got SolarWinds down here checked as well, but we got that out of the 62443 as well. So we go to our business decision makers. We say, let's make our security posture stronger. 62443. We want something stronger than that. Let's try zero trust. Well, we got one extra green bar. Kind of, we're looking. It's a lot of work. We're kind of looking for better results. What else can we do? Well, maybe we've heard of, these waterfall unidirectional gateways. Let's see what they buy us. So for anyone who's not familiar with the technology, a unidirectional gateway is defined by NIST, the National Institute of Standards and Technology in the United States, defined by NIST 800-82 as a set of hardware in the center of the diagram here, a set of hardware that's physically able to send information only one way. There's a fiber optic laser in one circuit board. There's a fiber optic receiver in the other. There's a short piece of fiber between the two. You can send from one to the other, but there is no laser on the received circuit board. It's not physically possible to send any signal back through that fiber. So one-way hardware and software that makes copies of servers. So what does that mean? Let's say we have a historian server or a SQL Server database in the industrial network, and that database is, in a sense, the focus of IT/OT integration. This is a very common design. You put all of the information you want to be able to share with the business in one place, and then you configure your business systems to reach through firewalls and fetch that data from that one place. It simplifies the IT/OT design. Let's say we have that design. Let's say it's an OPC server or a historian server or a SQL server. The unidirectional gateway software logs into that server, asks it for all of its latest updates, all the latest data, gets that snapshot of state information, tags and values and parameters, converts it to the strange one-way protocol, sends it through the strange one-way hardware, and on the other side, logs into an identical server. If it's OPC on the inside, it's OPC on the outside. If it's SQL on the inside, it's SQL on the outside. We log in, nothing tricky. We don't reverse engineer anything here. You log in and you take that snapshot of that set of updates and you update the server on the IT network. And now anybody on the IT network, any system on the IT network that needs the data goes to the replica, goes to the copy, and has access to the data. All of the data that's allowed to be shared with the IT network is sitting there in the replica server, the historian or the OPC server. And anybody who needs it can ask for it. It's, the questions that get sent, the answers that get sent happen on the IT network. There's no possibility of sending those questions into the OT network, but there's no need anymore to send them into the OT network either, because the data is already out on the IT network and the hardware prevents you from any kind of attack. It doesn't matter if the bad guys have stolen every password on every account. It doesn't matter if they've got 0 days in every piece of software. It doesn't matter if they have a 0 day in the unidirectional gateway software, because to get those 0 day exploits, to get those passwords, to use them on the industrial network, you've got to come from the internet, through the IT network, through the gateway, to send that attack information into the network. If you can't send the 0 day exploits, if you can't send the passwords through the one-way hardware, nothing can touch the industrial network. So that's the theory behind the unidirectional gateway. What does it do for us? It wipes out almost all of these new attacks. It wipes out a lot of the old attacks. We're seeing greens down the road. What does it not wipe out? It does not wipe out the IT dependencies. If we have ticketing systems or custody transfer systems or labeling systems, if we have systems on the IT network that are essential to second by second, minute by minute operation of the physical process, then it doesn't matter how strong our industrial security is. If the IT network goes down, those systems go down, our process goes down. So that's sort of the red line here in the middle of this. That's where that comes from. We need to do our risk assessment very carefully if we want the OT system, the physical operations, to survive an IT compromise. How do we use this? Again, in my experience, business decision makers understand, when we're talking about risk to business decision makers, a lot of people say risk is consequence times likelihood. Okay, for stuff that happens every day, the a virus got loosed on the IT network. There were 23 of those incidents on our network last year. We can look at statistics. We can calculate probabilities. We can look at consequences. We can say the average consequence was, $8,000 to clear this out. We can multiply that. But when we look at, how often, so what's the likelihood that the entire European power grid will go down because of a cyber attack next year? Well, nothing is ever perfectly secure. So we know that the probability is not zero. But any number we put on it, the business decision makers, they're going to look at that. Where'd you get that number? They're going to see through us making up these numbers. So probabilities are a poor way to model high impact, low frequency events. And again, a lot of people use qualitative metrics. We've got our cybersecurity at a 7.3 posture. We need to take it to 8.2. That'll cost $8 million. Can I have the money? 7.3, 8.2. What does that mean? I do this for a living, and even I don't know what those numbers mean. But these decision makers, if you describe an attack scenario, someone looks over the shoulder, takes the password, enters it later, they understand the attack scenario, in my experience. And if you ask the question, is that acceptable that we go down the first time someone shoulder surfs? They go, no, that's not acceptable. And you can set the bar. You can go through you look at what is the simplest attack that our current security posture does not defeat reliably, and explain the attack scenario and say, can I have, $3 million to get rid of that risk? Yeah. What else have you got? And at some point, you're going to get to an attack that's so strange, so weird, they're going to go, we'll accept that risk. That just doesn't sound credible. But we want these other ones fixed. And now you've got a way to communicate with these decision makers. So a word about Waterfall, if I may. Waterfall is the OT security company. We invented the unidirectional gateway. We invented it back in, it was a gleam in the eye in 2004. The company was incorporated in 2007. Back then, that was when, various government authorities were talking about advanced persistent threats, which was code for Chinese intelligence agencies. And of course, a couple of years later, lots of other governments got into the game. And, that attack technique that was pioneered, that was the alarm bells were rung back then, was what's today called the targeted attack, where you beacon out directly or indirectly to a command and control center on the internet. The bad guys rendezvous and they operate the attack manually, remotely, to do their dirty business, whatever it is. And the unidirectional gateway was invented to defeat reliably that class of attack, to take that off the table, to take the infection path from the internet through the IT network, through any intervening network, into the OT network, off the table. So that's Waterfall, founded in 2007. We're installed worldwide. We're trusted by critical infrastructures all over the world. We're headquartered in Israel. We have partners and offices all over the world. So if you're interested, reach out to us. Some other resources, if you want to dig deeper, I've talked about the unidirectional gateway, but really the world's most secure sites, these are the sites I work with. They don't just buy a gateway and put their feet on the desk and say, there, I'm done. That's not what they do. The gateway becomes part of a bigger security program. And, the security program, sets the bar really very high. The goal that I observe in, the world's most secure sites, the goal they have is to reliably defeat all cyber attacks except those that use deliberately cooperating compromised insiders. And it's not that they do nothing about that. They engage with their governments, they engage with other resources to deal with that attack. It's just that it's very hard to deal with insiders reliably. And so they set the bar really very high. They ask different questions, they get different answers. One example, they don't ask the question, how do I protect the information? They ask the question, how can I get my physical operations protected from information? from attacks that might be embedded in information. So if you're interested in the methodology, secure operations technology that we observe the world's most secure sites doing, go to the Waterfall website. This is the topic of my 2019 book. It's not a book about waterfall. The word waterfall appears once in a footnote. It's a book about what the world's most secure sites do differently. But as a public service, Waterfall is distributing the book free of charge. We can ship reliably to some countries in the pandemic. We don't get reliable shipping to all countries, but go to the website, ask for it. We will take our best shot at getting the book out to you. I talked about the top 20 report. Again, the existing top 20 report is on the Waterfall website. You're welcome to download it free of charge. It is being revised. In about a month. You'll get an email saying a new version is available. And I talked about the threat report that came out with ICS Strive. It is reflecting the data in the ICS Strive website. It will be available on that website, probably in about 10 days' time. So it's in the final stages of production. Basically, the content is done. So resources available for you. As I said, the world's most secure sites, they set the bar really very high. And what you're seeing here in the graphic is a 62443 program versus that program with a single change, the unidirectional gateway. Makes a huge difference. Again, the people we work with aren't satisfied with that much green. They fill in a lot more green with other tools and techniques that I talk about in the book. But the fact is that one change, a simple change, taking out the IT/OT firewall and adding in a unidirectional gateway, dramatically improves the defenses on the OT side. And don't get me wrong, I'm not saying unidirectional gateways replace every firewall in the architecture. Inside the industrial network, there's a lot of firewalls in a best practice 62443 design. In the OT network, there's a lot of firewalls in a best practice the IT network, there's a lot of firewalls in the best practice IT design. What we're saying is that what we see, one of the things we see the most secure sites doing is adding a layer of hardware-based physical protection at the IT/OT interface to reliably defeat the targeted attack paradigm and a whole bunch of other kinds of attacks as well. And again, the top 20 is a tool to help you communicate risk. I encourage you to have a look at it. I encourage you to give me feedback. I'm on LinkedIn, Andrew Ginter. I'm writing my next book. I'm looking for feedback as to how effective the material I've produced already is. Let me know if you found it useful. Let me know if you didn't find it useful. Negative feedback is every bit as important as positive feedback. Let me know. And thank you for staying with me. This is what I had for you. Do we have any questions in the queue?
We actually do have quite a number of questions, and I've tried to filter through them and put them in order. I think the first one that would be best to address would be a data diode versus unidirectional gateway. The question came up a couple of times. Is this what we know as a data diode or a diode device, or what's the difference?
Yes. So a lot of people refer to the hardware at the center of the unidirectional gateway as a data diode. I mean, if you Google data diode, and I do this from time to time, the last time I did this, in the first dozen pages of hits on Google for the term data diode, I counted 50 or 60 data diode vendors. Who are these vendors? Every one of them is providing hardware and maybe a little bit of software, hardware to their local military, because you use data diodes to send information into classified networks with no risk of leaking national state secrets back out to the world. The difference between a data diode and the unidirectional gateway partly is, the packaging of the hardware. Industrial packaging is different from military packaging, but most of it is the software. Because in the military space, you don't need to make a copy of an OPC server. You don't need to make a copy of an Oracle server. A lot of the stuff that you see in the military space is custom. It's custom engineering is the business model. So yeah, it's roughly the same kind of hardware, but NIST defined the term data diode differently from unidirectional gateway. 62443 uses the term unidirectional gateway exclusively because the diodes really are a good fit for military needs, not so much industrial needs. That's the difference as I understand it.
Mhm. Okay, and there are a couple of questions here that I'm going to apologize because I'm going to merge them together. The question refers to the unidirectional topology and how it works for things like SQL replication, database replication, but how does it relate to real-time processes like command and control, I guess also remote support and that type of thing?
Okay, so let's do two different questions. Hold on to remote support if I lose track of it, but we're going to hit real-time protocols. Two answers to that. One is where you put the gateway, and the other is the actual protocol. So I got three answers here. Let me start with sort of the simplest one. Generally, we do not see the gateways deployed between the HMI and the PLC. The HMI has to be able to control the PLC. You've got to be able to send commands to the physical process. And so, you know, in theory, you could put a gateway in each direction, but it gets complicated. Nobody does that. They put the gateway at the IT-OT interface where almost all, 99% of the information flow is from the industrial network out to the IT network. Almost nothing comes back. I mean, how many cell phones on the internet are supposed to be able to control my 2 gigawatt power plant? None. Yeah, but if I have you know, a VPN set up and remote desktop, I can get a VPN app from my VPN on my cell phone, can't I? Yeah. I can get a remote desktop app for my cell phone, can't I? Yeah. So the fact that I've set up this remote access, you know, has let myself, you know, the people we work with say nuts to that. Almost all the data is outbound. I'm going to talk about support in a second. Almost nothing comes in. There should be nothing on the internet or even the IT network that controls physical operations. This is why I have a control network. And so you don't place it between the HMI and the PLC, you put it at the IT-OT interface. The real-time protocol question, if you do need to expose a protocol like Modbus or DNP3, let's use DNP3. You know, let's say there's protective relays that you want to monitor. The engineers on the IT network, if there's a trip of the relay, they want to see the trip information that second so they can decide, can I turn the power back on? Do I need to dispatch a crew? Is this a lightning strike, which is a transient fault and it's all done? Or is it a tree hitting a line? It's a persistent fault. You need that data out on the IT network. You might need it on cell phones. If you are polling, and let's say you poll once a second, poll all the registers once a second, well, then what's your latency? It's on average half the polling period. And now you've got two pollings. You've got the gateway polling the device, and you've got your system, whatever it is, a historian, polling the gateway. It goes from a half-second average latency to 1 full second average latency. But DNP3 also has something called report by exception. If a report by exception comes through, the gateway can immediately say, oh, here's some data, and send a little snapshot update of state information, you know, registers and values through the hardware, make it immediately available on the other network, issue a report by exception to the historian or the cell phone or whatnot. And then the latency becomes milliseconds.